Well, this looks like a pack of fun. Students will be able to find inverse trigonometric ratios. Ooh, so what are we doing if we want the inverse ratios? Well, let's send some of these dogs on their way. And of course, the top dog's showing up. The Huskies, UW. Woof. Okay, quick reminder, SOHCAHTOA is still going to come into play. Sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. Tangent opposite over adjacent. If you've not yet memorized that, please do. Okay, so if we want the inverse ratios, again, I have to have a right triangle, and we have to study one of the acute angles, right? We're not going to look at angle C. We'll look at one of the other angles. So if tangent of A is x, the inverse tangent of x would give us the measurement of angle A. And in this diagram, opposite over adjacent, BC is the opposite side, AC is the adjacent side. Sine will work very similarly. If sine of A has a value of y, the inverse sine function of y will get us the measurement of angle A. Again, there it is with the actual ratio shown in that diagram. And then, of course, inverse cosine will complete us. Again, if cosine of A gives me some sort of value such as z, the inverse cosine of z will get us the measurement of angle A. And again, if you want to refer to the diagram, that would be the ratio. Now, this crazy -1 that we just saw a moment ago, let's take a look at cosine as an example. The -1 is telling me that it is an inverse function, not a reciprocal. Right? You're used to seeing like 5 to the -1 power, and oh, 5 to the -1 power, that's 1 over 5, right? You just do the reciprocal. That -1 works as an exponent with a plain old number. But when you have a function, that -1 is not a traditional exponent. Instead, it's warning me, hey, you're doing an inverse function here. So when I see cosine -1x, it's actually the arc cosine of x, right? It's an arc cosine function because there's so little room on calculators that those buttons almost never ever say arc cosine. Instead, they'll just have the cosine -1. So arc cosine refers to the arc that creates the ratio. So if the cosine of 60 degrees is 1/2, arc cosine of 1/2 would be 60 degrees. In other words, the arc or the angle that makes a ratio of 1/2 for cosine would have to be 60 degrees. If we actually wanted the reciprocal, right, if I really wanted 1 over cosine of x, that is the function secant of x, which we will explore in second-year algebra. Okay, so the reciprocal of cosine is secant, right? If I see that cosine with that -1, I am not talking about secant. I'm talking about the arc cosine. And of course, if you've looked at IXL, you'll notice that even though we're doing geometry, you go to the geometry tab in IXL, and they're ready for all these crazy reciprocals, which is great for sine, cosine, tangent, but not for the other three, right? So the reciprocals, um, we're just not going to go there. Okay, it just gets too crazy too fast. They'll be next year in Algebra 2. And sometimes as I'm talking in class, or in this case in the virtual classroom, sometimes I might say inverse cosine, sometimes I might say arc cosine. They're the same thing, right? Inverse cosine, arc cosine, those terms are interchangeable. Okay, so I better hang on to my good friends here, my special right triangles. And now, without touching a calculator, let's go for some exact values. Cosine is 60 degrees. As usual, if you want to pause this and try to figure out the answer before I reveal it, that's groovy. Well, I don't have a choice which angle and which triangle I have to use. I must stand in the 60-degree corner, remembering, of course, my SOHCAHTOA. And if I stand in a 60-degree corner and I need adjacent over hypotenuse, right, because cosine is adjacent over hypotenuse, it looks like I need 1/2. Okay, now, what if I want to do the inverse cosine of root 3 over 2? Okay, so I need to find a root 3. Well, I don't have any choice. I only see root 3 on that 30, 60, 90 triangle. So I know cosine is adjacent over hypotenuse. So where am I if adjacent is root 3? Well, if the adjacent is root 3, I must be at the 30-degree angle. So inverse cosine of root 3 over 2 is 30 degrees. Right? That's the angle I'm standing in to get the ratio of root 3 over 2 if I'm talking about cosine. Tangent of 45. Well, I have to pick the 45, 45, 90 triangle. I can stand in either corner, but opposite over adjacent is going to be 1 over 1. It does not matter which 45-degree angle I choose. Opposite over adjacent is going to be 1 over 1. Like I'd leave the answer as 1 over 1, right? I reduce it. Okay, so what if we want to play with inverse tangent then? Arc tangent. Okay, so I've got root 3. Uh-oh. I thought in trig we also had ratios. What on earth is a root 3? I'm going to rewrite this as root 3 over 1, because that way I can actually see a ratio. So root 3, it looks like I must use the 30, 60, 90 triangle. So where am I standing if the opposite is root 3 and the adjacent is 1? Well, I must be in the 60-degree angle. Root 3 is opposite 60 degrees. 1 is adjacent to 60 degrees. So 60 degrees would be my answer. Okay, so we did cosine, arc cosine, tangent, arc tangent. I guess we better do sine and arc sine. Sine of 45 degrees. Okay, again, I've got to do the 45, 45, 90 triangle. Pick one of the 45-degree angles. And sine, of course, is opposite over hypotenuse. So it looks like my answer is going to be 1 over square root of 2. Uh-oh. Square root in the denominator. We do not leave square roots in the denominator. Oh, well, there are two things I'm also allowed to do in math. I can always add the number 0 and not change the value, or I can multiply by the number 1 and not change the value. In this case, I'm going to choose to multiply by the number 1, but I'm going to disguise the number 1 as square root of 2 over square root of 2. In the numerator, when I multiply, I get square root of 2. Denominator, One way of doing it is thinking of this as being square root of 2 times square root of 2 makes square root of 4. And of course, square root of 4 simplifies to be plain old 2. The other way I could have thought about that is I could have said, oh, square root of 2 times square root of 2. That would be square root of 2 squared. And the square root and the square cancel out, leaves me with plain old 2. Arc sine of 1/2. Uh-oh. Now, if I just concentrate on that numerator of 1 and think, ooh, opposite is 1, I might be fooled and go to the incorrect triangle. Right? I got to make sure that, okay, even though there's a bunch of 1s in that diagram, right, both triangles have a 1. I got to make sure I use the triangle that has a hypotenuse of 2, right? I don't want 1 over root 2, I want 1 over 2. So if opposite is 1 and hypotenuse is 2, where am I? 30 degrees. Notice I highlighted the 2 first because I said, hey, I got to make sure I'm picking the correct triangle. And so I actually focused that the hypotenuse was 2. And then I focused on the opposite being 1. And then I said, oh, I must be in a 30-degree angle. Okay, now what if we want to play around with some inverse trig functions? And what if we don't want to just play with our 2 favorite special right triangles? So here we go. So let's find the sine of theta if we know that the arc cosine of 6/7 equals theta. What should I do? Dramatic pause. If you don't see a picture, draw a right triangle. Label one of the angles with a theta. Don't worry about how it looks, right? Because I'm not going to be able to make sure that, you know, if one of the legs is supposed to be 3 and one of the legs is supposed to be 1, I'm not going to have it really look like one of them is 5 times as long as the other, right? You can't just look and say, oh yeah, the long leg has the right length, the short leg has the right length, oh yeah, the hypotenuse has the right length. Don't worry about it. You just need a triangle so you can put labels, all right? Got to have a right triangle, pick one corner, put theta in it. Okay, so our clue is that arc cosine of 6/7 is theta, so I'm using cosine. And cosine, of course, is adjacent over hypotenuse. So the arc cosine of adjacent over hypotenuse equals theta. So the clue I'm using says, oh, the arc cosine of 6/7 gets you the angle theta. In other words, the adjacent side is 6, so I can put that on the triangle. And then the hypotenuse has to be 7, and I can put that on my triangle. Okay, so I just want the sine of that angle. Well, sine is opposite of hypotenuse, so I'm just going to grab the opposite side, which is, better figure it out. A squared plus b squared equals c squared. C must be the hypotenuse, so c is 7. 6 could be either a or b, does not matter. Notice that this time I'm going to show the subtraction horizontally instead of vertically. Right? I subtracted 36 from each side of the equation. Sometimes just to mix it up, I'll do it that way instead. A is the square root of 13. Let's slap that label on my triangle. Now again, square root of 13 should be much smaller compared to 6 and 7. Don't worry about whether or not the triangle looks correct or whether or not the triangle's to scale, right? Square root of 13 is less than 4, so that side should be much smaller. Don't worry about how the picture looks. You just say, hey, I can get my answer now. The sine of angle theta has to be opposite over hypotenuse, And so the answer is square root of 13 over 7. Okay, let's find tangent if arc sine of 2 root 2 over 3 gets us theta. Again, if you don't have a picture, draw one real fast. Right triangle, put theta in one corner. If sine of theta is opposite over hypotenuse, that means arc sine of opposite over hypotenuse equals theta. So that 2 root 2 has to be my opposite side. Put it on the triangle, opposite angle theta. The 3 has to be my hypotenuse. Put it on the triangle where the hypotenuse belongs. Tangent is opposite over adjacent. Okay, I know opposite. Let's figure out adjacent. Pythagorean theorem. A squared plus b squared equals c squared. C has to be 3. And then the 2 root 2 I can put for either A or B. 3 squared is 9. That's easy. 2 root 2 squared. Well, I need 2 root 2 times another 2 root 2. And of course, the 2 times the 2 is going to get me a 4. The square root of 2 times square root of 2 is going to get me a square root of 4. Square root of 4 is plain old 2. 4 times 2 is 8. Let's subtract 8 from each side of the equation. Again, I showed my work horizontally instead of vertically. A squared equals 1. So A is going to be the square root of 1. Oh, that's 1, right? 1 times 1 makes 1, so that's the square root. So for our answer of tangent theta, oh, wait, first I better put that 1 on my triangle. And again, it's ridiculous if I just look at it and try to say, hey, the side that says 1 is almost as big as the side that says 3. Right, don't worry about the scale. Right, I just needed a place to put numbers. Tangent is opposite over adjacent. So there I go. I've got the opposite of root 2 over 2. Adjacent is 1. Oh, come on. I'm not going to leave it like that, am I? 2 root 2 divided by 1 gets me 2 root 2. And so today, because IXL gets a little bit crazy with us, and they like to put all 6 trig functions in there instead of just the 3 that we're going to be using this year. We've got a worksheet, but we do not have an IXL assignment today. I'm sure that's going to be heartbreaking. I don't know if this video was a little bit on the lengthy side. The next one for the next lesson will be a little bit shorter. Thanks for bearing with me.